Okay, so this is about the color components. I had to show you about wavelet at too many number of codes, and I'm running short of time. Actually, Srividya madam need to proceed on with the other session. Do we have Srividya ma'am in the session?
Yes, my ma'am has joined now.
Has joined. Okay. Let me finish up with this wavelet decomposition, Srividya ma'am. Then you could proceed.
Sure.
Yeah,
Go on.
Okay. So this code is actually for wavelet decomposition. Wavelet transform is so interesting component. Actually, I do not know how much you know about wavelet, but wavelet transform is very important type of transformation, mainly for compression. Okay, so wavelet transform is I need to 1 second. I'll just take on pen. Okay, so wavelet transform is actually discrete wavelet transform. We generally represent it DWT, and here in terms of image we just use two-dimensional DWT. Okay, two-dimensional discrete wavelet transform. What is happening in this two-dimensional discrete wavelet transform is that we will be performing two separate one-dimensional transforms. Okay, so first, originally the image, if I have an image called X, okay, and the image is actually having m number of rows and I'm having n number of columns. Okay, let us take it as having just with the way that I'm writing. Okay, just listen to me orally, that will be better. Okay, so if I have an image X which is having m number of rows and n number of columns, I'm passing it through decimator. Okay, it means that it's going to be with an analysis bank. I presume that people are familiar with decimators, interpolators, sampling rate conversion, because you've learned signal processing already, so you'll be familiar with that. So you'll be passing through some analysis bank. That means you'll be passing on through the filter bank, decimator. Decimator means you'll have a analysis bank followed by, precedingly you will have the anti-aliasing filter, or you can call that as an you can have it as a decimator preceded with an analysis filter bank. Okay, so what is happening here is I'll pass it on through a low pass filter as well as a high pass filter. Okay, and then I'll perform the decimation. Okay, this decimation is with the factor, if I consider this decimated with the factor of 2. Okay, so what we get at this end is the original image corresponding low frequency components will be obtained here, and the high frequency components will be obtained here. Okay, so this is the row processing, which I have done now, is completely called as the row processing. And after this row processing, I'll again pass it on through the column processing. What happens here is, again I'll have a low pass filter. Okay, again I'll have a low pass filter, and I'll again have a decimator with the decimation factor of 2. Again I'll have a high pass filter. Okay, again we'll have a decimation with a factor of 2. Okay, so what you get at this point is, I have this low frequency components taken in, and again I have done the low frequency components happened here, so I'll have the band to be low band. Okay, whereas at this point I'll have it as low frequency, high frequency component. So I'll have it as I'll have it as low H component. Okay, again here I'll be passing it on to two factors here. Okay, the same thing. So the same thing which I have here, we'll have a low pass filter, and it will be passed on through a decimator. Okay, it will be passed on through a decimator here, which a factor of 2. I'll have an output. Okay, again here I'll have a high pass filter. This will be a high pass filter, again passed on through decimator with the decimation factor of 2. So okay, so I'll have the component here. This becomes a high-low band. Okay, and here it will become a high band. Okay, high band. So it's all quad operations. Okay, so this is actually one level of decomposition. This is, I could say that this is going to be the first level of decomposition. Why do you do discrete wavelet transform is, we know that where you have the maximal information necessary for the image to be contained is actually in this low frequency component. Okay, in this low frequency component you have maximum information, or in this among these low, high, low and high band, I have wider information contained only in this low band. Okay, so if I want to proceed again the second level of decomposition, what will happen is this low band is again passed on through a low pass filter and a high pass filter. I'll get low and low high. Okay, and low and low high. Okay, so accordingly we go on with various levels of decomposition, and ultimately even if you represent the image with such very low band alone, and you could neglect all these components. Okay, though you neglect all these components, the image can be efficiently transmitted or stored. That saves a lot of space. Okay, either in the channel or in the storage. That will save you a lot of actually storage space in the channel bandwidth, or the other way.